In this video, we're going to take a quick look at the net change theorem. So here is the net change theorem from our textbook. So this is the new value of a changing quantity equals the initial value plus the integral of our rate of change. So your rate of change is your derivative, so the integral of your derivative. And really, this is just a different way of writing the fundamental theorem of calculus. It's just taking that fundamental theorem of calculus and kind of quantifying it and phrasing it a slightly different way. And it's having us look at, how our quantity has changed as we started at A and we've gone all the way to B. So we don't really use this any differently than we use our formula for the fundamental theorem of calculus, because that's what it is. So really what we want to talk about is really, what does it mean when we talk about net change versus total change? Because that is something that's kind of important. So let's take a quick look at an example here. We've got a particle moving along a line with a velocity function of v squared minus, or v of t is equal to t squared minus t. There we go, where v is measured in meters per second. So find each of the following. We want to find first the displacement, which is just a different way of saying the net distance that this particle has traveled on an interval. So when you're talking about displacement, which is kind of a word that we use in particular when we're talking about motion, but it is the same as the net distance that you traveled. This is our regular old integral. So exactly what we're used to, find that antiderivative, and 0 to 5, plug in 5. I'm going to have to stop doing all of these on these videos. It takes so much time here. Oops, minus 0, but it is nice that this one's 0. And we get 175.6 meters is our units, and this is approximately, if we kind of want to know a little more what this is. 29.17 meters. So this is our net distance traveled. So kind of what this means and what the difference is, if we're talking about, say I'm here at home in Corvallis and I drive up to see my brother in Beaverton. At the end of that drive, just that drive, the net distance that I traveled is the distance between my house and Beaverton. But if I look at my entire trip, sort of my round trip going from my house up to Beaverton and back, then the net distance I traveled is 0, because I went all the way there and then I came all the way back. So this is the difference between talking about sort of net distance and total distance, which is what we want to ask the next time. So what's actually the total distance that's traveled, that this particle's traveled on this interval? So what we actually want to find here with the total difference is actually the absolute value of this function. We want to take the integral of the absolute value. There we go. Let's say it that way. So we need to know a little bit more about this function before we can actually do this. So one of the things that we need to do is figure out is if there's any places where this crosses the x-axis in our interval. Because we kind of want to figure out, is there a place where we're getting negative area, right? Because any area that's below the x-axis, that's negative area. Any area that's above the x-axis is positive area. So if we set this equal to 0, we get t equals 0 or t equals 1. So what this means in terms of like the graph of this function and, sort of the interval that we're concerned about, 0 here to say 5, here's 1, our graph's going to do something like that. It's going to be a quadratic. It's going to start at 0, and we're going to have negative area there, and then we're going to have positive area. So what is happening with this particle and its motion is, if this is sort of our starting point here, when we talk about motion, generally we talk about, going forward or to the right equals sort of the positive direction, and to the left is negative direction. That's kind of fairly standard, but it doesn't have to be that way. But the idea is, I kind of like thinking about it that way, is that it's like it starts out and it's moving backwards for a little bit, and then it turns, and then it's moving forward. So the motion of our particle looks something like that. So there's this little bit of time where it goes back, and then it wraps around, and then it starts moving off forward and positive. So what we need to do is actually split up this integral and look at it from 0 to 1 and then from 1 to 5. So we want this negative area here from 0 to 1, but we want it to be positive. We want to change it. So that's where that absolute value comes in. We want to actually take that part of our graph and flip it up here to the positive x-axis. So we just literally want to flip it over so that when we take the integral, we get positive area versus negative area. And all we have to do that is change the signs of our function. We have to literally just, anything that's positive becomes negative, anything that's negative becomes positive. That flips that part of that graph up. We're just going to do that from 0 to 1. From 1 to 5, we're going to keep everything the same. And we're going to add these two together. So it's going to take that negative area, make it positive for us, and then keep our positive area positive. So, what's nice about this is we've already found this integral. It was just opposite when we did it earlier. So it's really the same for both of these. And from 1 to, not 2, it's 1 to 5. And then let's grab a different pen color here. So here, we're plugging 1 in. And, oops, not t anymore. That's now a 1. And then minus 0. So that's our first integral that we're looking at. And then our second one here, that's going to be the 1/3, 5 to the third, plus 1/2, 5 squared, and then minus 1/3, 1 cubed, plus 1/2, 1 squared. So what we get from all of this is that from this first part here, we get positive 1/6. Then let's switch back to the purple here. Then we get 175/6 from this first part, and then minus negative 1/6. So what's happening here now, if you kind of look at our numbers here, we've got 1/6 plus 175/6 plus 1/6. So those 1/6 is over here kind of on our motion. That's our negative motion going backwards, and then this positive motion as we go back towards the start and get past it. And then lastly, that last number is this positive motion here. So let's maybe kind of underline those things in the corresponding colors so we kind of see them here. And oops, that one was blue. So we'll make it blue. There we go. And so then that's adding on that positive and that negative motion that was overlapping and gives us 59 halves of a meter, or 29.5 meters. So that's totally how far it moved. So that's the idea of saying, instead of saying, my net distance traveled when I go see my brother and in Beaverton and come home is 0, I would say that I traveled that positive distance up to Portland, that negative distance back down to my house. I would add those two together, and that would give me my total distance.